So my name is Samir Khan, and I have the absolute pleasure of speaking about a tool I've been very close to for the past 5 or 6, I think even longer than that, 5 or 6 years. The tool is MapleFlow, and I tend to think of MapleFlow as a mathematical sandbox, something that I can just jump into, do a few simple calculations, maybe build up something more, generate a document, and I get a sense of pleasure when I use MapleFlow. I hope that pleasure is self-evident throughout this presentation. And I think if you're the right type of person, if you enjoy technical computation tools, you'll get pleasure out of using MapleFlow as well. It's an enjoyable tool to use with a lot of feedback. I find that matters a lot when it comes to designing tools that are enjoyable to use, instant feedback, a sense of tactile feedback about the tool. So I'm going to walk everyone through MapleFlow. I'll start off by showing you a complete worksheet, and I'll talk about the contents, its structure, what you see in it. And then after that, I'll dive into a few more features in detail. Now, most of these features you'll be able to use today, but maybe 1 or 2 or 3 features will be in the next version of MapleFlow that we're going to release, probably within the next 60 days or so. So without further ado, let me get started. So I'm just going to dive straight into our in-product application gallery and load up one of my favorite engineering worksheets. I think this one. And I'll talk everyone through what we see here. So a MapleFlow worksheet is just a blank canvas, and what you see here is a worksheet that we've already prepared. We've placed all of the text, graphics, images, math on here, and we've moved everything into position. So we have a title, we have a description of the problem, we have a diagram that we've simply copied and pasted in from another application. If I click on the diagram, once I've brought it in, I can actually annotate the diagram, write text on it, draw some attention to parts of interest. But if I scroll down, I can see math and text. Now, everything you see is in a box that I can move about. So I can just grab text, grab math, move text into place, and so on. In fact, at any point, I can type in my math, define my variables, do my computations. It's pretty simple to use. It's like a free-form whiteboard. So throughout this worksheet, you see a number of concepts. So my parameters are specified with units as well. So, but I can chop and change parameters. So instead of millimeters, I can specify this parameter in inches. My results have units as well. And of course, I can play about with units, rescale the results to dimensionally consistent units, and so on. Now, a MapleFlow worksheet updates automatically. So if I change a parameter value, let's make this unfeasibly large. If I press enter, those changes cascade down the length of my MapleFlow worksheet, and all of my results, dependencies, update to reflect the new parameter value. Now, MapleFlow, the worksheet, represents a document. It contains the math, the text, and the entire problem statement. The math is live, so you can go in, change parameters, results update automatically. And on top of that, you can also write text. You can capture the knowledge and the assumptions inherent in your analysis and more. And one common goal of many MapleFlow users is to create a worksheet that they convert to a PDF. Now, if you want to see what this worksheet, this PDF will look like, you can do that very easily. If I select this option, you'll see horizontal and vertical guidelines across my worksheet, and these represent my pages. Now, when I convert this to a PDF, what you see is what you get. It'll be a faithful reproduction of the original MapleFlow canvas. Now, there's a lot to MapleFlow, and in any presentation like this, I can only ever touch on the very tip of the pyramid. What I do want to talk about are some highlights, things that I enjoy using in MapleFlow, things that you might find of value. I'll talk about our tools for calculation and productivity, documentation and reporting, connectivity and deployment, and the ability to migrate work from other tools as well. But let's just start with math, and I'll talk about maybe all of these features in turn. So MapleFlow is built on top of the Maple mathematical engine. What does that mean for you? It means you have access to a whole bunch of solvers, numeric tools, symbolic math tools, tools for matrix math, tools for solving differential equations, probability, statistics, tools for working in phasor notation, optimization, data analysis tools, and there's much more as well. In fact, in the entire Maple programming language, there's probably about 6,000 or 7,000 functions with many different options covering virtually every area of mathematics, science, and engineering. There's a lot there. What I usually find is that if you sit down with MapleFlow and you start using it and you start creating your own worksheets, you start solving your own problems, you discover little tools and features that help you become more productive. For example, there are many mathematical features in MapleFlow which are targeted towards various topics in science and engineering. Let me mention a few. So, for example, did you know that there's a full database of thermodynamic and thermophysical data in MapleFlow for pure fluids, fluid mixtures, gases, and solids? So here's a few examples. So here I'm extracting some thermodynamic data for ethanol using temperature and pressure and states. You can see I'm using units here, and if I change the value of temperature and pressure, you can see results updating. You can chop and change states as well. So instead of temperature and pressure, you can specify temperature and entropy. Here you can see that I'm evaluating the enthalpy of a 50-50 molar mixture of ethanol and methanol as well. I can also extract the properties of humid air. So here I'm extracting the wet bulb temperature of humid air using the dry bulb temperature, the relative humidity and pressure as states. There are lots of thermodynamic visualizations and atmosphere models as well. There are tools for analyzing the stability of linear systems as well. So one common use case for electrical engineers is that they use MapleFlow's tools for symbolic math to derive circuit equations, manipulate them into the correct form, and then they perform some stability analysis on those transfer functions by generating phase and magnitude plots. So all of these plots are created inside the software. There are lots of different plotting tools, and hopefully I'll get to show you some more as the presentation progresses. All of the features are really easy to extract as well. So let's say that I wanted to extract the gain margin of my transfer function that I'd specified earlier. That's simple enough to do. There's a number of tools to help you become more productive when you're doing analysis like this. So command completion, syntax highlighting, and more. There are tools for signal processing as well. So here I'm simply reading in an audio file and generating a periodogram and a spectrogram. I can apply filters, I can downsample and upsample the data. If I'm working with irregularly spaced data, I can generate periodograms for that. There's a lot there. Now, there are many more mathematical tools in MapleFlow, and in a presentation like this, I won't have time to cover everything. So these are just some of the highlights that I use on a regular basis. Moving on. You can also program in MapleFlow as well. So as well as doing simple calculations, evaluating functions, you can also write programs. Now, there are several different ways that you can write programs in MapleFlow. So you can write programs inline. So here I have an inline procedure. It's a simple to use high-level programming language. This is simply, I think, a procedure which calculates the Fibonacci series recursively. And let me just evaluate this for a different parameter. And there we go. Now, to help you create inline programs like this, we have a programming palette with a convenient series of templates that you can just insert, and then you can simply complete the placeholders like so. It's simple enough to use. So this is a simple procedure. You could also insert for loops, if else statements in there, and more. Now, for larger programs, things which are a bit more complex, things which require more finessing, we also have a coding window. And this is an example of a program in a coding window. This program is larger and it requires a bit more care and attention to develop. But I'm using exactly the same programming language that I use within the worksheet. This environment, however, offers me features like syntax highlighting, bracket matching, automatic indentation, command completion, and more. There's also a diagnostics window as well to help you locate errors in your code. Once you've developed your procedure in this programming window, you can actually evaluate that procedure inside the worksheet. So this is the procedure that I defined in my coding window, and here I'm evaluating it at different parameter values. It's simple to use. So moving on. I also have a variables palette as well, here on the left-hand side. Now this is really useful. This is a tool that I use all the time. This palette gives me the value of all the variables that I've defined at the point of my cursor. So if I click up here, the variables palette is empty, but as soon as I start moving my cursor down, you can see more and more parameters that I've defined in my worksheet appearing in the variables palette. Now, this is really useful because a MapleFlow worksheet can be non-trivial. It can be dozens of pages. It can contain hundreds of parameters. And it's difficult keeping mental track of what you defined at what point. So this is just a convenient tool just to help you keep track of everything. And here's an interesting trick. So if you double click on a parameter from the variables palette, that's actually inserted inside your worksheet, ready for you to work with. Now, there's another feature about this worksheet, a documentation feature that I really like. This worksheet actually contains sections that I can expand and collapse at will. And if I right-click on something like this, if I select this command, show commands, you can see that there's actually a layer of code behind that evaluation. It's hidden away though, because quite often I don't necessarily need to see everything here, so I can conveniently hide this away and create a cleaner looking worksheet. Let me close down some of these worksheets. So I've already shown you a couple of plots. There's a really broad range of plots and visualizations in MapleFlow. These are all created with simple functions. So for example, if I want to plot a sine curve, I can do that very simply. With command line parameters, I can alter the look and feel of this plot. There are psychometric charts, contour plots, 3D plots. You can create completely customized plots as well. And there's much more there as well. Now, one of the more forward-facing productivity features we have is an AI formula lookup assistant. Okay, let me show you how this works. So there's a tab on the left-hand side called AI Formula Assistant. All I do is type in a natural language query for an engineering formula or a scientific formula, click on search. Mapleflow communicates with an AI on the back end and returns a number of formula. So I can select the form I want, and if I click on insert, that form is inserted directly inside my worksheet. Let me evaluate this. There we go. Simple to use. So here are some other examples of the types of queries you could use. So I could ask it to give me the resistance of 5 resistors connected in parallel. It would return this formula. I could ask it to give me the deflection of a cantilever at a point X with some combination of point loads and distributed loads. This is what it would give me. I could ask it to give me a correlation for the density of seawater as a function of the brine content, and it would actually give me this equation, which I've actually cross-checked against other sources, and this is absolutely correct. But this is a really useful productivity tool. Let's move on to some more documentation and reporting features as well. There's a tool in Mapleflow to help you create diagrams. So if I go to the document tab, I can insert a drawing. This is a simple drawing interface which allows me to create simple line diagrams, add text, arrows, and so on. If I import images into Mapleflow, so if I go to the document tab and let me import an image that I've already got on my computer, if you'll bear with me. If I import an image, I can draw on that as well. So it's simple enough to import an image. What I can do is simply drag an image that I already have on my computer into my interface. So if I drag this image into my worksheet, it appears there. Once this image is inside Mapleflow, I can simply annotate it, draw attention to various parts of that image, and I can also annotate plots as well. So let me just create another plot. If I click on this plot, you'll see a drawing tab, and I can then highlight interesting aspects of this plot as well. I can also automatically generate a table of contents based upon headings and subheadings that I've defined in my Mapleflow worksheet. So back to this worksheet. Here you can see that I've defined various headings and subheadings in my Mapleflow worksheet. These are all given various styles. So if I want to define a table of contents, I simply go to the document tab, select table of contents, and it appears right there. So all of the entries are taken from whatever headings and subheadings I've defined in my Mapleflow worksheet. And this table of contents is actually hyperlinked. So I can simply click on a link at the table of contents, and it jumps to that part of the Mapleflow worksheet. And these hyperlinks and the table of contents are actually preserved when you export this to a PDF. So the table of contents will be hyperlinked in the PDF as well. Now, there are lots of other documentation features I can talk about as well, but I'll just leave those for the moment, and let's move on to connectivity and deployment, because this is really important, because engineers and scientists and other technical professionals don't use Mapleflow in isolation. They use Mapleflow in combination with other tools, whether it's a programming language, whether it's another engineering tool, or whether it's just a spreadsheet. And you want to be able to effortlessly pass information from one tool to another. So one common tool is Excel. You can actually interactively execute Mapleflow worksheets from Microsoft Excel. And this is an example. So here we have a Mapleflow worksheet that sits on an Excel spreadsheet that communicates with a Mapleflow worksheet. Let me show you what that Mapleflow worksheet looks like. It's this Mapleflow worksheet. I'm not going to go into it in too much detail, but you can see I've defined some parameters in here, like dtest, mtest, and height. And I have some results as well, such as this power here. So I have a nicely presented worksheet. It's easy to read, it's easy to understand. But there may be a community of users who don't need to see all of that detail. All they're interested in is the ability to change a few parameters and see what the updated results are. They're not really interested in what goes on in the middle. And this is a perfect solution for them. Using the Mapleflow add-in for Excel, you can set up a communication channel between your Excel spreadsheet and Mapleflow. So if I click on this cell, you can see that we have an additional Mapleflow command that points to a Mapleflow worksheet, and the rest of the command define the inputs and outputs. If I change a parameter here, let's change that to 0.5, Excel sends that updated parameter into the Mapleflow worksheet, re-executes the Mapleflow worksheet, and gives me the updated results. So this functionality is easy to use. I simply fire up this interface, the Mapleflow worksheet wizard. I can then browse to select a Mapleflow worksheet. I'll select this one, the one I just showed you. If I select load variables, this interface will display all of the parameters I've defined in that Mapleflow worksheet. So I'm going to select some as inputs, and I'll select a couple as outputs. Now, if I click on Insert, you can see that Mapleflow has placed this into my Mapleflow worksheet. And if I click on here, you can see the same Mapleflow command that points to this Mapleflow worksheet. So this is just the basic form of the results that are returned. This certainly works. So for example, I can chop and change inputs and outputs. I can play about with units as well. So I can specify this value in inches instead of meters. But using Excel's functionality, I can make this more pretty, make this more accessible, and generate an interface that looks like this. So for example, if I wanted to, I could have drop-down list boxes in Excel which allow me to pick the units. This just makes working with a more complex Mapleflow worksheet easier for the casual user. You can also run Mapleflow from Python as well. And this is just an example. So here I have a Python script And here I'm running that Python script inside a Python IDE. I'm doing exactly the same thing that I was with the Excel, with the Mapleflow add-in for Excel. I'm simply sending in updated parameters to a Mapleflow worksheet, recomputing that worksheet, and then extracting the results. If you want to see it running live, here we are. This is just my Python script. I'm pointing to the Mapleflow worksheet, and I can simply change parameters, run the script, and it gives me the updated results. Now, you could do the same with C#, you could do the same with Java, Perl, MATLAB, and many other target code bases. I showed you the ability to write programs in Mapleflow earlier. Once you've prototyped a program in Mapleflow, you can actually convert that program, that procedure, to another target language. This is just a simple example. Here I'm just prototyping an algorithm to solve an equation numerically. So this is the equation that I want to solve numerically. Here's my numerical equation solver that I prototyped in Mapleflow. You can see that it uses elements like exponential powers, natural mathematical notation. If I want to highlight all the keywords in my program, I can do that as well. That's pretty simple to do. Once I've used Mapleflow's interactive environment to test the correctness of the algorithm, I can then convert that procedure to another target language. So here I've converted that procedure to Python. If I wanted to, I can convert this to Java, C, Perl, Fortran, or a number of other target languages as well. So you're not just walled in inside Mapleflow, you can move your work in and out as well. There's also a unique ability in Mapleflow to call a worksheet as a black box function from another worksheet. So here I'm simply pointing to the compressor power worksheet that I've shown you earlier. I'm sending in values of diameter and I'm extracting some outputs. This is actually a parameter sweep. If you think about it, if I want to rerun this worksheet for each value of diameter, this is an independent process because none of the sweeps rely on each other. So I can actually run this in parallel on my computer. So when I do something like this, Mapleflow automatically distributes all the runs across all of the cores of my computer. So 10 runs won't take you 10 times as long as one run. It'll take you much less time. I can also do some pretty interesting things as well. So I could turn a worksheet into a function that I can compute with in Mapleflow. So here I'm simply back solving the compressor power worksheet I showed you earlier for another parameter. So for a power output of 4 megawatts, I want to know what the initial diameter of my wind tunnel is. And here are my results. As you can see, this functionality is fully compatible with the unit system as well. So my numerical equation solver returns the diameter in centimeters. But of course, I can rescale this to another unit as well. Now, many of our customers are joining us from other tools. So Mathcad is another popular calculation tool. People have often developed a large library of worksheets in Mathcad. We have tools for converting Mathcad worksheets in XMCD format to MapleFlow formats. Let me show you an example. So here, I've conveniently placed a number of Mathcad 15 worksheets in XMCD format. This is a PDF conversion of one of the Mathcad worksheets. So I just have images, text. I'm doing some analysis on some matrices, and here are my results. In MapleFlow, if I click on this button, this fires up the migration assistant. I can browse to my folder of worksheets. I think it was this one. And if I click on this button, MapleFlow cycles through all of those worksheets, extracts the relevant content, and puts them inside a MapleFlow worksheet. For moderately simple Mathcad worksheets, there's usually a 100% success rate. For more complex Mathcad worksheets, the conversion process might generate a worksheet that's 75% complete, and you might have to do the final 25% by yourself. But here are the worksheets that it's just generated on the fly. And if I load up this worksheet, you can see that this is the Mathcad worksheet in MapleFlow format. The results are the same. It's converted this function in Mathcad over to the appropriate function in MapleFlow. We've also produced a migration guide as well. So if you're joining us from the Mathcad world, you'll obviously have questions about what the automatic converter can do, what it can't do, and we've documented that faithfully inside this guide. This is freely available. There's a function conversion table in here as well, and there are also tips for converting non-converted Mathcad content manually as well. And some of our customers actually employ our services for turnkey migration services. So they might have existing work in Mathcad, in Excel, in MATLAB, and we have the expertise and the tools to move that content from those tools into MapleFlow format. So that was a whistle-stop tour of MapleFlow. As I think I've said, in a presentation like this, I can only cover the very tip of the pyramid. There is much more to MapleFlow. So I'd be more than happy to engage with anyone listening with a personalized demonstration where I can answer your specific questions. Before I progress onto the questions, I'd just like to summarize what we've spoken about in this presentation. I demonstrated MapleFlow. We spoke about the tools for calculations and analysis. I hope it was clear that the math engine is simple to use. It's units aware. And I find that as soon as you start using MapleFlow, you'll find little tools and features just to help you become more productive. So there's a suite of tools for signal processing, thermodynamic data. There are tools for extracting the values of all the variables in your document, for creating tables of contents. You can also use MapleFlow to document your analysis as well. The reports are simple and easy to understand. You can hide parts of the document which aren't necessary for the casual viewer or for the auditor, and you can quickly navigate through your worksheets with the use of hyperlinks, bookmarks, table of contents, and more. I also spoke about our tools for connectivity and deployment because we don't want Mapleflow to be a walled garden. The file format is open, it's XML based. That means you could open it up in your text editor and look at what you've done. You can interface with many different tools. You can run Mapleflow from Excel, from Python, from other programming languages as well. And there are many import and export file filters as well. So, for example, you can import and export data from spreadsheets, images, ComTrade files, and more. And of course, if you're moving to us from other tools, we have a full suite of migration services. These range from automated migration tools to turnkey services where we take all your work and implement it in the best possible form in Mapleflow.